In this session, we will study about the permutations and combinations. Let us see the meaning of permutation and combination. Permutation means arrangement. Permutations is arrangements, and combination selection. Now we see an example. So what is arrangement and what is selection? We see an example. We have 5 letters A, B, C, D, E. A, B, C, D, E. We have to select 3 out of these 5. How many ways we could select this? We see here we could select ABC, ABD, ABE, ACD, ADE, ACE, BCD, BDE, PCE, and CDE. We see how many ways we could select this. Here we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 ways we can select 3 letters out of 5. Now we see the arrangement of these. We see how many arrangements are there. We see the arrangements of ABC. ABC, we can arrange ABC in this way: ACB, BAC, BCA, CAB, or CBA. So we can arrange these 1, 2, 3, 4, 5, 6 ways. So the one selection we could arrange in 6 ways. There are 10 selections we could arrange in 6 into 10 ways. So we can arrange the data in 60 ways. Okay. Now we see this sort of technique is very hectic, very difficult, very tough to find, to arrange, to write all the things and then calculate, or we can miss someone somewhere. So it is very difficult. So we have the techniques of permutations and combinations for this. That is very these are very simple techniques of permutations combinations, by which we could easily find out the arrangements and selections of the numbers of the things. So let I tell you first about the permutation. Permutation, the formula of permutation is n permutation R is equal to factorial n minus R. There is a condition for this. 0 is smaller than R is smaller than equal to n. It means n permutation 0 is not possible, where n is the natural number. So n permutation 1, n permutation 2, up to n permutation n you can easily find out. Now what is factorial? Factorial n. What is factorial n? We see the factorial n here. The factorial n, if we have to write out the factorial 5, so factorial 5 is 5 into 4 into 3 into 2 into 1. The number itself and less than it, the product of these numbers, is called the factorial. Now the factorial 4, 4 into 3 into 2 into 1. Factorial 3, 3 into 2 into 1. Factorial 2, 2 into 1. Factorial 1, factor 1, and factorial 0 is also equal to 1. So this is the meaning of factorial. Now we will put the values of 5 and 3 here in permutation. We see what happens. So 5 permutation 3 factorial 5 minus 3 is equal to 5 into 4 into 3 into factorial 2. In denominator factorial 2 is there. You see here it is equal to 5 into 4 into 3, which is equal to 60. So here this one 60 and this one 60. So in this way we can easily find out the arrangements of the things by permutation. Now we see the combination. N combination R is equal to factorial n factorial R factorial n minus R. There is also condition 0 is smaller than equal to R is smaller than equal to n. N combination 0 is possible. N permutation 0 is not possible, but n combination 0 is possible. Now here we put again the values. We put 5 combination 3 is equal to factorial 5 factorial 3 factorial 5 minus 3. It is factorial 5 factorial 3 factorial 2. It is 5 into 4 into factorial 3 upon factorial 3 into factorial 2 is always factorial 2 is 2. We could write factorial 2 is 2. Factorial 3 and factorial 3 will eliminate. 2 1s are 2, 2 2s are 4. So it is equal to 5 into 2, which is 10. So here you see this thing is also correct. The 10 ways of selection we have seen here. So in this way, through these techniques, we could easily find out the arrangements of selections of the numbers of the things very easily.